Greetings to all and welcome to the session 5 of the unit 1, which covers getting started with solid edge, protrusion, cutout and advanced modeling future. It covers the course outcome CO1 of MCAD laboratory for third semester diploma mechanical engineering. So in the today's session, we are discussing the following content: getting started with the solid edge, creating base feature by protrusion and cutout, advanced modeling tools, small multiple choice question at the end of the session. Getting started with the solid edge. Solid edge is a Windows based software. The environment setting and startup methods are similar to the any Windows application. So for starting the solid edge, you have to go for the start menu, search for the solid edge software and click on that. Also, you can keep the one shortcut on the desktop. So by double clicking on that also, you can open the solid edge. Next is creating base feature by protrusion and cutout. So protrusion is one of the basic command in the solid edge. So protrusion is defined as the process of creating feature by adding the material defined by the sketch along the direction normal to the sketch. So for drawing protrusion, you need a closed sketch profile and the material added perpendicular to the sketch drawn. So it is nothing but creation of 3D solid part by a 2D sketch. Let us discuss the protrusion command with the live example. So initially when you open the solid edge, you can see this screen. So these are called as planes. This is front plane, this is top plane, and this is side plane. So these planes are very important for drawing sketch and solid parts. So here comes your protrusion command. Click on the protrusion command. Select the reference plane about which the sketch has to be drawn. So sketch draw ಮಾಡಕ್ಕೆ ನಿಮಗೆ ಏನು ಪ್ರೊಫೈಲ್ ಯಾವ ಪ್ಲೇನ್ ಬೇಕು ಅದನ್ನು ನೀವು ಇಲ್ಲಿ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. So I will select the front reference plane. So once you click on the reference plane, it will automatically moves into the sketch mode. Here you have to draw the protrusion command. Make sure that your sketch is closed one. So I'll draw a simple rectangle and I'll give the dimension for the rectangle. Here. Once your sketch is completed, click on return. Make sure that your sketch is closed one and click on return. See here, now the material is adding perpendicular to the sketch drawn. So here we have two options for protrusion. One is non-symmetric extend. It is non-symmetric extend. Non-symmetric extend means it will add the material in one direction only. If you keep the cursor in this direction, the material will be added in this direction. If you keep the cursor here, the material will be added in this. Here next we have symmetric extend. Symmetric extend means it will add the material equally in the both direction. If you enter 100 mm here, 50 mm will be added in this direction and 50 mm will be added this direction. So I'll enter here 100 mm depth of the rectangle. So here 100 mm the depth, total depth, and 50 mm is added in this direction and 50 mm added here. It is the symmetric extend. So click on the finish. So this complete the protrusion command. I have drawn a simple rectangle and I have added material perpendicular to the rectangle sketch I have drawn. So next we'll move on to the revolved protrusion command. What is revolved protrusion command? It is similar to the protrusion command, but here the material will be added about the reference plane. So circular cross-section materials, circular cross-section parts such as cylinders, shafts, cones, stepped cones. These components are produced by revolved protrusion command. For revolved protrusion command, you need to draw a closed sketch profile and you have to define a reference axis about which that section has to be revolved. The material will be added by revolving that section about that reference planes. So let us discuss this revolved protrusion with the live example. File, new. Okay. Here next to the protrusion, we have a revolved protrusion. Revolved protrusion command, click on that, click the reference plane. Once you click on the reference plane, the sketch mode. Here you have to draw the closed sketch profile. Here, this is the closed sketch profile, and you have to define the axis of revolution for this sketch, which has to be revolved. So I'll select this axis of revolution command and click this reference plane. Now this section will be revolved about this axis and it will add the material. Click on the return command. See here, the material is adding by revolving this section about this axis. You can give any finite angle if you know, or you can give full 360-degree. I'll enter full 360-degree. Here, the material is created by revolving this to full 360-degree. So this is about the revolved protrusion. Click on finish. Here. Next, we'll discuss swept protrusion command. So what is swept protrusion? It will add the material by extruding the profile along an open or closed path. So for swept protrusion, first you need to draw the section and you have to define a path about which the material has to be added. So you have to define both sketch for a section and path. So let us discuss with this swept protrusion with the live example. File, new. For swept protrusion, first you have to draw both section and profile sketch. So I'll draw the path and section sketch first. I'll draw the path for the swept protrusion first. Go to the sketch, select the reference plane. I will draw a path here. So this is my path. So now I'll click on return. So the path is created, and now you have to draw a section. For drawing section, the plane should be perpendicular to this curve. For drawing the plane perpendicular to this curve, we have one here. Go to sketch. Here you click on plane normal to the curve. So I need a plane normal to this curve. So to draw the section, click on this plane normal to the curve and click end point of this curve as my, see here. The plane is created perpendicular to this curve. So you can keep anywhere here, but I need plane here at the end of this curve. I'll select this end point. Now it will move to the sketch mode. Here you have to draw the section for the swept protrusion. So I'll draw one circle here and click on return. So this is your section now, and this is your path. The material will be added by this section along this path. So now click finish, then go to the swept protrusion option. Click on single path cross section, OK. Select the first, then click OK. Now select the section. Here, material is added by the section and the path defined. So these kind of options, models, commands are used to draw the elbow pipes. You can see this. You can easily draw the elbow pipes with the swept protrusion. So next we'll move on to the lofted protrusion. So here in the lofted protrusion, you can add the material by blending across the two cross section. You can see here, this is one cross section, this is another cross section. You can add a material by blending these two cross section. You can add more than two cross section also. So let us discuss this lofted protrusion with the live example. File, new, part, okay. Now you have to draw two different profile for this. So I'll draw one simple sketch here. Select the sketch, select the reference plane. I'll draw one circle here. Click return. So this is my first section. Again, you have to draw the second section, and you have to by some distance. For this, you have to shift this plane to some direction, some distance. So click on a sketch parallel plane. Select this plane. Now you can give the distance. If you know the particular distance, you can give. I will enter 200. See here, the plane is created 200 distance from this initial sketch. Now I'll draw another section. You can draw any section here. Return. See here, two cross section. The material will be added by blending these two cross section. Click finish. Go for the lofted protrusion. Select the first sketch, then select the second sketch. View preview. See here, the material will be added by blending these two cross section. You can give more than two cross section also, and you can give any different cross section. This is for only the simple example I have given circle. You can give any cross section. Click on finish. Next, we'll move on to the cutout option. Cutout option means it is created by removing the material defined by the file. So it is opposite of the protrusion command. For cutout option, you need a already drawn solid part. From that solid part, you can remove the material by drawing any profile. Similar to the protrusion, here you have to draw the sketch for removing the material. Let us discuss this cutout command by the live example. Suppose I want to remove some profile here, so I have to draw a profile here. So then go for cutout option here. Click on cutout option. Select the reference plane or surface about which the section has sketch has to be created. I'll select this reference plane. Now I'll draw the any sketch profile here. Click on return. See here. Now the material is removing here. Now you have to give the depth here. I'll give 100 mm. And you should have to keep the cursor in the downward direction because there is no material in the upward direction. So you have to keep the cursor in the downward direction. See here, finish. The cutout is created here by the sketch I have drawn. I have drawn a rectangle, so it is removed the material by the sketch I have drawn. You can draw any profile here. According to that, the material will be removed. Next, we'll move on to the Revolved cutout operation. What is revolved cutout operation? It is similar to the revolved protrusion command. Here the material is removed instead of adding. There the material is added by revolving the section about an axis. Here it is similar to that, but here only the material is removed by revolving the section about an axis. Let us discuss this revolved cutout with the live example. Here, go for revolved cutout operation. Below the cutout, we have revolved cutout operation. Click on the planar surface about which the section has to be created. This reference plane. Then I will draw the closed sketch profile. Return. This is the closed sketch profile, and you have to define now the reference axis. Here comes the reference axis option. I will define this as a reference axis. The material will be removed by revolving this section about this axis. Click on return. I will give full 360-degree here. Here, this profile is rotated about this axis and the material is removed. This is about the revolved cutout operation. Here, you can draw any profile which you want, and the material will be removed accordingly. So this is about revolved cutout operation. Next, we'll move on to the advanced modeling tools. In advanced modeling tools, we will discuss hole and thread. Holes and are created to assemble the two or more components. The hole may be simple one or threaded one. The simple hole may be used for oiling purpose, and threaded holes are used for fastening or assembling two or more components. So let us discuss this hole and thread option with the simple example. Go to the hole operation here, hole command, click on that. Then you go for again the hole option here, click on this. Here the type, if you give the simple type, it will go for only simple hole creation. If you want a threaded hole, then you have to click for the threaded hole operation here, threaded hole option here. Once you click on the threaded hole, you will get a standard threaded size here. I will select any standard hole size. Suppose I will select M30 into 3, M30 into 3 mm pitch. M30 into 3 mm pitch. Here there is two options, to hole extent, to finite extent. To hole extent means whatever depth the hole you have created, up to depth, that depth the thread will be created. Finite extent means to a particular depth. If suppose the hole depth is 50 mm, you need a depth of thread to only a 10 mm, you can enter here. So I will click on to hole extent. So throughout the whole length, the thread will be created. So I'll click on this. Next here, there is option for hole depth here. This indicates through all, means if any surface is there, throughout that surface, the hole will be created. So this option through next, that means through next surface, the hole will be created. If there is a 4-5 surface, up to the next surface, immediate next surface, the hole will be created. This is from to extend. You have to select the from where you have to require a hole, and from where from up to which surface you have to end the hole. You have to select from and next surfaces, and this is finite extents. Here you can enter the particular depth which you want. I'll enter here 60 mm length. Click on OK. Now it will ask for reference plane where the hole has to be created. I will click this reference plane. So now it will ask for the location of the hole. I will click exactly at the center. If you know any particular dimension, you can enter the dimension here. Click on return. See here, the threaded hole is created for 60 mm length. Since I have given threaded hole to a hole extent, so same the thread will be created for 60 mm depth also. So you cannot see, initially you cannot see the threaded hole here. To see the threaded portion, you have to go for tools, format, view, click on. So you can see the thread here. See here. The thread is created for whole depth of the 60 mm length. So this is about holes and thread. Next we'll move on to the round and chamfer. What is round and chamfer? This is called as round and this is called as chamfer. So these are used to remove the sharp edges of the component. Sharp, if you keep the sharp component as it is during transportation or during handling, it will damage the human hands. So in order to avoid that, the round will be created on the sharp edges of the component. Round edges, it will remove the sharp edges by a radius, whereas the chamfer removes the material by a distance and angle. So let us discuss this round and chamfer with the live example. Normal part. I'll draw one sketch, protrusion here. Here, round and chamfer. If you click on round, it will ask for the edge and corner. Click on edge and corner option. Select the edges where you require the round. Select this edge, this edge, this edge. Whichever edge you want, you can select. So here it is the radius. You can increase the radius. I'll keep it as 10 mm. So whatever radius you are, it will maintain a radius here. So I have given 10 mm radius, so it is maintained 10 mm radius here. Click on preview, finish. See here, the material is removed by giving 10 mm radius here by round option. So now I'll give chamfer here. Then I'll go for chamfer option here. It will ask for edges and corner. I'll click this edges. Then it is asked for giving setback. So you have to give the setback here. So I'll give 10 mm setback here. The material is removed by setting 10 mm distance from here to here. So you can give any setback distance. Accordingly, the chamfer will be created. Now you can see the difference between the round and the chamfer. This is round option. It is removed the material sharp edges by a radius, whereas this has removed the material by a setback distance and an angle here. Click on finish. Now we'll move on to the mirror copy feature. What is mirror copy feature? It enables the mirror, enables to mirror the selected feature about the selected reference plane. See here, there is one feature here. If you want to draw a same feature in this surface, again, no need of drawing this same profile here. Instead of this, we can select this feature and can you mirror about the reference plane. Let us discuss this mirror feature with the live example. So draw one feature here. Suppose I want this same feature, this reference plane. You can mirror this reference plane with mirror this feature with reference to this reference plane. Click on mirror copy feature. Select the feature. This the feature I have to mirror. Select this feature, and then you click on OK. Then you click the reference plane. It has maintained the same distance from here to here and here to here. Similarly, you can draw any profile and you can mirror this. And more than one also you can mirror. Click finish. So this is about mirror copy feature. Next we'll move on to the rib. What is rib? A rib is defined as a thin wall-like structure used to bind the joints together so that they do not fail under the increased load. Suppose you have two surfaces like this. See, under the increased load, it has joined at this corner. So under the increased load, these two surfaces may fail and this joint will be failed. So in order to avoid this, the rib will be created like this. So it will take up the load of these two surfaces and will make the strong bond between these two surfaces. So how to draw the rib in a solid edge? Let us discuss. I'll draw one simple protrusion to draw the rib option. Now, these two surfaces are weak and it is joined here. In order to avoid failure of these two surfaces, we'll create a rib here in the center or any distance. So, for drawing rib option, you go to the rib option here. This is the rib option here, the future command, future toolbar. Click on the rib, and it will ask for the reference plane about with the where the rib has to be created. I will select this reference plane. If you don't have the reference plane, then you have to create the reference plane by parallel plane. So I will, it is in the exactly in the center. So I will select this reference plane. And click coincident plane. Here. It will go for the sketch mode. Here you have to draw the rib profile. So I'll draw a simple line. You can draw the profile from here to here also. Here. Then click on return. Here. Direction is very important here. If you keep this rib in this direction, there is no surfaces here. So it will take the error. So keep the arrow marking below downward direction and give the thickness here. I'll give 5 mm. Here. Finish. Here, the rib is created now. 5 mm thickness rib is created. Now this rib will take up the load of these two surfaces and make a strong bond between these two surfaces. You can see these kind of ribs in the plastic chairs. Below the plastic chair, you can see these ribs. So this is about creation of a rib. Then we'll move on to the what is macros here. Macros is nothing but it is collection of polygon. So here in the polygon, here in the solid edge, instead of drawing every time pentagon, hexagon, you have a default of command for drawing polygon. Just you have to select the number of sides and with the flat length, the distance between the flat length. So if you know these two options, you can easily draw the polygon. Instead of drawing each and every line every time, you can call the macros option and you can directly call for hexagon, pentagon, octagon. So let us discuss with the live example. So for calling macros command, you should be in a sketch mode. So go to the sketch mode. Then go to the, you have to follow these steps in order to call the macros. So go to the you have to follow these steps. Go to application, macros, run macros, C drive, program files, solid edge, custom n-sided polygon, bin n-sided polygon. There you have to call these macros. So I'll go to the application, macros, run macros. Initially it has followed a path, but I'll tell you the where it is available. Go to the C, Windows C, go to the program files, go to solid edge, go to custom, here n-sided polygon, go to bin, here comes the n-sided polygon. Here. Here you have to run the flat length. Go for flat length option. This is the flat length here. I will draw a simple hexagon by this polygon method. Here you have to draw the flat length. If flat length will be given and give the number of side as 6. I'll give 30 mm flat length. Whatever length you have, you can write here. Then it will ask for the location where you want this polygon. Here. Instead of drawing single line, again you have to give for angle. You can directly call the hexagon with the macros. It is very useful for drawing solid part. Then we'll move on to the next option. So here it will be the end of this session. So we'll discuss one small multiple choice question. So first question is, solid edge work on which software environment? So initially I told you that SolidWorks works on a Windows application. So here the correct answer is Windows. We have the options Ubuntu, Windows, Linux. The Mac is a iPhone operating system. The Linux is another operating system. Ubuntu is another operating system. But the solid edge work on Windows software environment. So next is protrusion command in the solid edge is used for. So we have discussed the protrusion command. So it is option we have creating hole, revolved part, removing the material, creating solid part from the sketch. Creating hole is a hole option. Revolved part is a revolved protrusion. Removing material is a cutout operation. whereas the creating solid part from the sketch is the protrusion. This is the correct answer for protrusion command. Cutout command is available in which toolbar? So initially I told you the cutout operation, protrusion command, everything is available in the futures toolbar only. So correct answer for this is futures toolbar. The sketch is used to draw the profiles. The pattern is used for copy, and tools are used for toolbars. So future is the correct option. Which command creates by extruding a profile along the open or closed path? Which command creates the part by extruding a profile? So I told you we have discussed swept protrusion. The swept protrusion is created by defining a sketch and a path. So here the correct answer for this is swept protrusion, whereas cutout is used for removing the material. Revolved protrusion is used for adding the material by revolving about the reference axis. Lofted protrusion is used for to draw the two sections by blending them. Next is which command creates the part by joining two or more different profile along the path. The correct the options available is swept protrusion. In swept protrusion we have only one section and path, whereas revolved protrusion we adds the material about revolving about and reference axis. Lofted protrusion is used to draw the part by blending two different sections, and this is the correct answer for this. The command creates the part by joining two or more different profiles. So we are joined the two circles. So this is the correct option is lofted protrusion. Thin wall-like structure used to bind the joints together so that they do not fail under the increased load. In the end, we have discussed the rib. I told you the rib will take up the load of the two surfaces which are weaker in the joints. So rib is the correct answer for this. Draft is a draft angle used for pattern allowances. Chamfer is remove the sharp edges. Cutout is removing the material from the by drawing a profile. So correct answer is rib. Next, the last question is which command in solid edge is used to create the default polygon in sketch mode? So in the end, we have discussed about the macros, where I have drawn a simple hexagon by entering sides and a slot length. This is macros. So the pattern is used for copying the future. Mirror also used for copying the future, and mirror copy is also used for creating a copy of the pattern. The macros is the correct answer. Thank you. This is the end of this session. Thank you. Thank you all.